Alright, we just left off with this example, which got pretty algebraic. But just remember that those negative exponents means we can drop them down and turn them positive, and then we can deal with them from that perspective, or we can just add exponents if we have the same base, and we can think about it that way. Okay. Now how this relates to scientific notation. We use negative powers of 10 to write small numbers in scientific notation. And by small numbers, we mean numbers between 0 and 1. So we'll be talking about numbers between here, and there are an infinite amount of numbers that are in between there, if you can imagine that. They can get very, very, very small. Alright, so positive numbers named with negative powers of 10 is what we're talking about here. So these are all positive, and they have to be, because if they're above 0, they're not negative, okay? Even if their powers are negative. So if we want to write this number in standard form here, this is in scientific notation with a negative exponent, we can think about it as, well, let's first imagine what 10 to the negative third means. Remember, that means we can drop that, and it's over 1. So it's 1 over 10 to the third, or 1 over 1,000, 10 times 10 times 10. So it's 1.5 times 1 over 1,000, or 1.5 divided by 1,000. And that tells me that when we divide by 1,000, we're going to move our decimal 3 spots to the left. However, we have a little shortcut, just like we would do with our large numbers for scientific notation. Remember, if we had like 4.2 times 10 to the 4th, this was times what? 10,000, and we would get, we'd move our decimal 4 spots, so it would be 1, 2, 3, 4, and we would get 42,000. Our shortcut was to just move our decimal 4 spots to the right. If we have a negative exponent, guess what? We can move that decimal 3 spots here, but we're going to move it to the left this time because it's negative. 1, 2, 3. And then we can still fill those with zeros, so it'll be 0.0015. Alright? So that's our shortcut there. Scientific notation still follows those rules. The only difference now is you have to pay attention to whether we're being multiplied by a negative power of 10 or a positive power of 10. Okay. We can also take a small number like this, and we can write it in scientific notation. Same rules apply. We want to make sure that our first number is between, it's equal to or greater than 10, not greater than 10, equal to or greater than 1, but less than 10. Sorry about that. So we want our first number to be less than 10 and bigger than 1 or equal to 1. And we got to figure out how far this has to move over. So we're going to go in between. We want 7.0 times 10 to the something. Now how far do I have to go to get here, basically? 1, 2, 3, 4, 5, 6 times 10 to the negative 6. So that means if I did this, we'd move it 6 spots to the left, and we should get this for an answer. So this would be the scientific notation version of that number. Alright, we'll compare these two numbers here real quick. 1 times 10 to the negative 6 and negative 10. Which one's bigger? Alright. This number right here is, so it's basically 1.0 times 10 to the negative 6. Negative 6 means we're going to move this to the left 6 spots. 1, 2, 3, 4, 5, 6. Fill these with zeros here. And what's bigger, this number or this number? Well, this is a very small number, but it's still positive. And if it's still positive, that means it has to be bigger than negative 10. This number is bigger than 0, this number is less than 0, okay? It is a very small number, yes, but it's bigger than 0, this one is not. So don't let this fool you. This doesn't mean you have a negative number, it just means you're moving your decimal to the left and you'll get a small number, okay? Alright. And that's all I've got. So we'll talk about this more tomorrow and probably the next day as well.